So after half term, this drill then is what I'm going to be asking you to do. Let's go through them one at a time. So number one, y equals lambda. This symbol here looks like this. To draw it, I usually do a little curly line down like that and then put a little leg on it. Lambda. L-A-M-B-D-A, part of the Greek alphabet. Often used to represent wavelength. So you have the formula y equals lambda x minus d all over d. And we have to rearrange it for d. What might you do first? Could get rid of the lambda, divide both sides by lambda. So what would I end up with, Miles? Divide by lambda equals x minus d over d. Could do that, yep. Then what might we do? Get rid of the brackets. Well, there is actually nothing outside the bracket now, so really I didn't need that bracket, so let's get rid of the bracket. There you are, done. It's easy. It's all divided by d, isn't it? So what would I do? Times both sides by d. d times y over lambda equals x minus d. Now the problem here is that d, which is what I'm trying to isolate, is on both sides. And the common trick in this case is to get all the terms involving d on the same side. So I'd add d to both sides. d y over lambda plus d equals x. So I get all terms involving d together, and then I factorise. What does that mean, factorise? Take a common term outside the bracket. So I'm going to introduce a bracket here, take d outside the bracket. What have I got to times d by to get the first term, yd over lambda? What have I got to multiply d by to get y times d over lambda? Y over lambda. So times that by d, I get y times d over lambda. What have I got to times d by to get d? 1 equals x. So now, to get d on its own, I would divide both sides by that whole bracket. d equals x over y over lambda plus 1. So, divide both sides by lambda to get rid of the lambda, which takes you to this line. And then, to get rid of the d on the bottom, multiply both sides by d. So the d goes up to the top on the other side. d times y over lambda is x minus d. And then, because I've got d's on both sides, add d to get all the d's on the same side. Add d to both sides. And then factorise, take d outside the bracket, and then finally divide both sides by the bracket. And you've got d on its own, okay? Those are the sorts of steps. Let's have another look at this for a second. Oops, that's not what I meant to do. Copy this. Now, your suggestion, Miles, to divide both sides by lambda is fine, okay, and it gives us an answer, which is this answer over here, and that's perfectly acceptable, okay. However, there's another way we can do it. If instead of dividing both sides by lambda, I would multiply both sides by d first, I'd get y times d equals lambda x minus d. Now, by doing that, I've now got no fractions. By dividing by lambda, which is we did on the previous slide, I've actually introduced another fraction on the left-hand side, right, Miles? If we look at this one, there are now no numbers underneath. So that might make it a bit more straightforward. Let's see how we go and decide whether it does. What I would do now is multiply out the brackets on the right-hand side. So I'd get yd equals lambda x minus lambda d. Multiplying both of those terms in the brackets by lambda. Now I get all terms involving d on the same side. So I add lambda d to both sides. And then factorize. D outside the bracket, leaving y plus lambda inside the bracket. And then divide both sides by y plus lambda. D equals lambda x over y plus lambda. Extension activity show that this formula, this solution, which is one, as Matthew says, one way of writing the answer, show that that's the same as the answer we got here. Because in theory, they're the same. They're both equal to d. So you could try and show as a little extension activity. I won't be asking you to do this in the drill. See if you can prove that they're the same. Yep. So there are some important steps in this question. Let's look at it. I've talked about these sorts of things before. If I've got fractions, particularly if the thing I'm trying to find is underneath, multiply through by it. So that first step, multiplying both sides by d, is useful in this case. Hopefully you can see why, because you've got rid of any fraction. It's just now there's no denominators in there. Another useful trick when the thing I'm trying to isolate is inside a bracket is to multiply out the brackets. So multiplying out the brackets is a useful thing to do. Once I've got to this point, notice that the thing I'm trying to isolate occurs on both sides. How do you get around that? Get all the terms involving what you want on the same side of the equation. I could have put them both over on the right-hand side, but then they'd have both been negative, so that wouldn't be very useful. So get them, if you can, positive, so I move them all over to the left-hand side. When I've got to that point, a useful trick, if the thing you're trying to isolate occurs more than once on the same side, factorize, take it outside the bracket. And then d, the thing I'm trying to isolate, only occurs once. So all I've got to do now is divide both sides by the rest, the whole bracket, and then I've got it. Okay? Those are useful things, and these sorts of steps occur in more than one formula. So the more of these you do, the easier they get. Okay. Let's look at number 2. I think you're asked for this one to rearrange for t. The thing we're trying to isolate is inside a bracket. Expand out the brackets. So what's the right-hand side going to look like now? R0 times 1 is R0 plus R0 times alpha t is R0 alpha t. Now, what we're going to do? What I've got is t multiplied by 2 terms, and also something's added. So what's the first thing to get rid of? The bit that's added, because that was done last. So subtract R0 from both sides. R minus R0 equals R0 alpha t. Finally, to get t on its own, it's multiplied by R0 and alpha, so what do I do? Divide by R0 and alpha. So R minus R0 divided by R0 alpha equals t. And I've done it. So finally I'd write it as t equals R minus R0 over R0 alpha. So to recap, multiply out the brackets. Good first step. I could have, instead of multiplying out the brackets, I could have divided both sides by R0, as we did in the last one, as Miles was suggesting, but that introduces a fraction, so possibly not at this stage, but you could do. Expand out the brackets, you get this. Then, as we've done before, get rid of everything on the other side apart from the t. We're after isolating the t. So I want to get rid of anything that's added first and then get rid of things that are multiplied or divided. So I get rid of R0 by subtracting it and then divide by R0 alpha, and I end up with this. Okay, let's look at the next one. The third one that I want you to, number 3. T equals 2 pi root L over G. That's an L, that symbol for length. This formula is to find the time it takes, the period, the time for a swing of a pendulum. It turns out it's got nothing to do with the mass of the pendulum, only the length. You divide the length by the gravitational, the acceleration due to gravity, square root it, and then multiply it by 2 pi, and you get the time for one swing of a pendulum. So there's a useful formula. But what if we want to rearrange it to get the length of the pendulum for L? Right, divide by the whole thing, divide by 2 pi. Divide both sides by 2 pi. Root L over G. Now that right-hand side is all square rooted, so how am I going to get rid of that? Square it, so I must square the other side. So I'll rewrite the other side and just square it. Put a bracket round it and square it. Equals L over G. Now finally, L is divided by G, so what do I do to get the L? Multiplied by G, yeah. So G times T over 2 pi squared equals L. And there's my new formula. L equals G times T over 2 pi all squared. Question 4 just reviews a few little algebra techniques, and this is something that we're going to be moving on after half term, looking at expressions like this and trying to simplify them. So this is asking you to simplify this. Yeah, x into 2x minus 4y minus 2x into 4x plus y. And basically what I'm asking you to do here is to expand those brackets and then collect like terms. So when you're asked to simplify something, that's generally what you do. So I'm going to multiply out those brackets to try and collect together things that are the same, like terms. So multiplying out the brackets, x times 2x gives 2x squared. 2 times x, 2x squared. minus 4 times y times x, yep, or for xy. We tend to write in alphabetical order, but yx is the same, but write it alphabetically. Minus, watch this one because you have to be careful with signs here, minus 2x times 4x is minus 8x squared. And the last one, minus 2x times y is minus 2xy. So be careful about the signs there. They end up both being negative. Now, if you look at this, I've got two terms that are the same. I've got two lots of x squared. So 2x squared minus 8x squared is minus 6x squared. And I've got two terms involving xy. Minus 4xy minus 2xy is minus 6xy. And that's simplified. I can go further. Because minus 6 is common to both of those, I can take it outside a bracket, i.e. I can factorise. And also, there's an x in both of those terms, so I can take an x outside the bracket. So I can actually factorise it and take a 6x minus 6x outside the bracket. What have I got to times minus 6x by to get minus 6x squared? X. Watch this one. What have I got to times minus 6x by to get minus 6xy? 2. Minus 6x to get minus 6xy, y. Okay? Positive. Positive y. Minus 6x times y minus 6xy. Okay? Area of a circle? Correct. Circumference of a circle? So we say 2. That's what you're thinking of, Jack. 2. You're thinking ahead. 2 pi r. Okay? 2 pi r. 2 times the radius times pi. Or, what's 2 times the radius? Diameter. So pi times the diameter is the other way to think of the circumference. Pi times the diameter, or 2 pi r.